we've got a real treat for you. I have the pleasure of interviewing Dan Jablonsky, CEO of Ursa Major. Dan has had an eclectic career. After graduating from the Naval Academy and serving as a surface warfare and nuclear engineering officer, Dan decided to go to law school with an emphasis on business and securities law. After practicing for several years, he returned to the government service by working at the Securities and Exchange Commission, prosecuting violators of securities laws. So Dan next moved to Flextronics, now known as Flex, to learn the intricacies of international M&A and corporate strategy. And interestingly, Dan was concurrently an adjunct professor at the University of Denver School of Law teaching M&A. So extending his reach again, Dan became general counsel at Digital Globe, where they quickly recognized his innate ability to lead. In 2014, he became the general manager of the U.S. Defense and Intelligence segment, growing the business to nearly $400 million before running the entirety of the Digital Globe unit after Maxar acquired it in 2017. In 2019, Dan was appointed CEO of Maxar, leading the company through a turnaround and eventually sold to private equity, having increased the stock price by 12x. At Maxar, Dan managed a team of 4,400 people in 20 locations all over the world. Dan became CEO of Ursa Major in 2024, having been recruited by Gilman Louis, a founding partner at Alsop Louis, and at the time, he was also a board member at Maxar. So Dan, let's start talking about leadership. One of the great qualities of the military is they imbue all of their members with leadership. And perhaps you can talk a little bit about your time at the academy and then as a young officer and how that led you to become a leader.
Well, first off, Joe, thanks for having me tonight. Thanks for Stanford for having us here as well. Really excited to be part of this discussion. I'm not so sure the military imbues you with leadership as that they test you, and they test you continuously. But it is a great leadership laboratory, starting at the academy where you get a lot of practical hands-on type of activity and leading small teams, and then sometimes leading larger teams to get things done. And then upon commissioning into the Navy, you get to your first ship and immediately you're in charge of 30 to 40 people as a very young officer in that environment, and also in charge of sometimes tens to hundreds of millions of dollars of capital equipment. My job was running nuclear reactors, and I owned all the mechanical systems for those on one of our capital ships very quickly. And I think what you learn very, very quickly is how to work with people to get things done, how to work in a structured and sometimes unstructured environment to be able to perform at very, very high levels.
So as a VC, I view one of the most important functions of a CEO is keeping your company properly financed. How did your tour as a securities lawyer help you with that?
Well, first off, I would wholeheartedly agree with you. We talk a lot about capital allocation, especially in a startup. We just finished our fundraise here, actually last week, right before we went on the Halloween holiday hiatus. And it's really important, especially as a startup, to be able to finance it appropriately and think through what the capital table looks like, who you're bringing in as investors, how you think about how you deploy that capital. Smart ways to use it. You don't want to run out of cash, obviously. We kind of talked about that a little bit in the break. But as a lawyer, having done an awful lot of financing, so I started out as a cub attorney at O'Melveny & Myers. O'Melveny has offices here in the city. It's also very prominent in Los Angeles. And I was doing a lot of venture work and IPOs back in the day. And I think it helped me quite a bit understand some of the intricacies of the fundraising environment, different capital structures you can employ or deploy once you have the businesses at hand. So I think it was a fantastic background. A lot of people go get MBAs. I kind of got mine through real world experience here in the Valley.
That's great. Well, you also spent a lot of time in your career in M&A, and M&A can really change the position of a company. Talk about some of the pitfalls and the benefits of M&A and how you've seen it used well.
I think one of the things about M&A, first off, it's fun. Like doing deals, if you get to do them, they're just fun. But it's a pretty high stakes game too. I think the statistics are lately about 2/3 of mergers and acquisitions don't actually perform to the level that the original business plans would indicate. Sometimes they can be even worse than that, complete and abject failures. And but they're a capital allocation decision. So you can take your company's capital, you can raise money to do things, you can do lots of things with that capital. One of the things you can do with it is mergers and acquisitions. You can buy and sell stuff. And I think probably the two of the biggest lessons I've learned are really rigorous diligence processes. The same kind the private equity, the VC guys would give you if they're investing in your company. You should be thinking about that with regard to any business you're going to buy, because it's never exactly like you think it's going to be. So grinding and doing all the hard work to really understand that business and figure out if it's the right match and a strategic fit. The other thing is there's got to be not just a strategic fit for that business, but a cultural fit as well. And being patient and finding the right ones to make sure that actually works is really important. But it also works on the side when you're selling things. So if you're in a big enough business, you've acquired different divisions and things. Sometimes things don't necessarily make the most sense in your portfolio anymore. And so having the wherewithal not to emotionally be holding on to things, but to really do the rigorous analysis of the cash flow metrics on the business and what it might eventually be worth and what it might unlock for your shareholders. So at Maxar, at the same time we were doing acquisitive M&A, we were also selling things. And my team is much better at the analytics than I was, but did an awful lot of work really trying to understand the way things fit together, the best way to enhance shareholder value, and the best way to then redeploy capital into the business as you increase shareholder value.
Oh, that's good. Let's now talk about Ursa Major a little bit directly. So what initially drew your attention to the company?
Well, Gilman was a big part of that. Known Gilman for a long time. Gilman and I actually met in 2015 when we were getting ready to form a joint venture with Saab to do artificial intelligence applications for unstructured data sets. And we brought Gilman in as a independent director, independent chairman between two companies that owned 50-50 and each had 2 board seats. So it was about as kludgy of a governance structure as you could have guessed. But Gilman did a fantastic job mediating between us and helping us advance that technology and advance that company. And after we acquired that company, we had a call option on it. I asked Gilman to join Maxar's board. And so we got to work together for a number of years together. And Gilman, and then I knew Joe Lorienti, the founder, and then some other investors, Leo Susan and the team here at Eclipse, asked me to initially come on as an advisor to the CEO and as a director, possibly chairman of the company. And the more and more I dug into it, the more I got to understand and like the technology. Its application, for those who don't know what we do, we're a defense tech company, but we're kind of on the hard side of defense tech, which is rockets, rocket engines, missile motors, hypersonics, space-based applications, stuff that makes other stuff move, sometimes really quickly across vast distances. And but I went in, I did a ton of diligence on the company. It had some things that really attracted me after we'd completed the Maxar transition, and I was on the bench there for a little while. One, it had some advantageous technology that it had developed. It had done the really hard work of pushing through some technology challenges. The second thing, it had a really passionate team of technologists there. If you walk onto our floor plates even today, you get this sense of this energy about the place, which is really exciting. And then the two other things that it had I think it's really an important part of the ecosystem for the United States and the Western democracies right now, developing defense tech that provides a strategic advantage as we think about it on the world stage. And then the third thing, it had been through some challenges as a business, and I saw an opportunity to bring in, some of my team, some of my skill set, to be able to enhance the shareholder value there. So we did a very good job doing that at Maxar. I see an opportunity, kind of a smaller scale, but I think we're going to grow into a very big company to create a lot of value for our shareholders, create a lot of value for our customers, and that's a really exciting place to have a business.
Mm-hmm. How about the ability to change the acquisition process in defense tech? Did you see that? Did you foresee that?
No, I really didn't. And I think by acquisition process, you're referring to, there's an awful lot of work going on in Washington, D.C. right now on changing or updating or morphing what has kind of become a bit of a sclerotic process over many, many cycles and years. And the team that's there now is very, very focused on making things work better and making things work faster. So that the Secretary of War is rolling out a major initiative on Friday in Washington, D.C. On this topic. Steve Feinberg, who's the Deputy Secretary of Defense, has been working very hard on really making sure that the United States, through its acquisition process for how it buys things, for how it purchases technology or equipment, can be as adept and fast and capable as we need to be as a nation. Because I think the pacing threats through peer nations and others are very much, sort of forces to be reckoned with. We haven't done that great in the United States, and if you look at some of the large programs that we've got that are perennially behind, how much we spend versus what kind of bang for the buck we get, it's not run real tight right now, and it's getting better, and it's getting better really quickly. Mm-hmm. But that's advantageous. So if you're a disruptor, if you're a startup, not only having a great product, not only having a great set of technologies and business ideas, but being in enough of a disruptive environment is really critical too. Because if it's very staid, and people will just keep playing with or going to the customers or the solution sets that they've got, there might not be an opening for a new entrant or a new disruptor. That's very much, that environment is very much to our advantage right now. That it doesn't mean we're going to win, but it means we've got a shot at inside that disruptive environment, having the opportunity to go compete. And that's really important as a young company.
Tell us about why propulsion is one of the biggest problems in defense.
Mostly because a lot of people aren't good at it, and it's essential to anything you're going to do. So if you think about strategic imperatives, whether they be across the vast reaches of the oceans, in the air domain, or in space, which is sort of the ultimate high ground, you not only have to have things that can interoperate and would work together, but they have to be able to move around. You can't just be sort of looking at stuff, watching the environment happen and hoping it gets better. You have to be able to move sometimes things, large assets, be able to strategically deny others access to areas, or to be able to operate in them yourself. And that means you have to be able to move. Moving that's just propulsion, that's what it is. And Ursa Major has taken on a lot of the hard tech of the rocket engine development, the hypersonics engine development, solid rocket motor development using new techniques to be able to move things around. Sometimes that means moving something very, very quickly, like an interceptor, to shoot something with something. Sometimes it means moving something strategically across a larger section of space, but in a sort of a time-dominant way. We call that delta V. That's the rate at which velocity happens in space. And then sometimes it means having a capability that can countermatch one of your strategic adversaries, so that you can actually hope them. The ultimate goal here is to never have to deploy these things. The ultimate goal is to, through strategic deterrence, keep others from acting against your country's interests. But you need to be able to have things that you can deploy in that environment. And for that, propulsion is essential. The United States is pretty much behind in a few areas. China, for example, develops and has much more robust manufacturing operations than we do in the United States. So we need to rebuild that type of capacity here, and we need to do it on 21st century, 2025, 2030 applications, not sort of technology from the 1980s and 1990s. We need to develop hypersonic technologies. China and Russia both have hypersonic capabilities, and we do not. So that's an area where we're lagging.
You say you do not, but you guys have flown 5 test missions, right?
We have flown multiple times hypersonically, and we have done so without a hiccup so far, which is really exciting. Hypersonic is Mach 5 plus, and not just something that's going Mach 5 plus, because if you put a satellite in space, it's actually going Mach 5 plus, 17,000 miles an hour. It's just not maneuvering in the atmosphere. The way we think about hypersonic is 5 plus times the speed of sound, so 3,800 miles per hour at sea level, and able to maneuver. So not just a ballistic, but something that can actually fly someplace where you want it to, and course correct, and speed up, slow down, and do some fun stuff like that. Yeah.
So the company
That's with our partner Stratolaunch, but we're getting ready to fly our own hypersonic missile by the end of the year.
The company spent 10 years developing the liquid propellant rocket engine before you got there, but you have expanded the company to create 3 different areas. Maybe you can talk a little bit about those. You touched on a little bit, but.
Yeah, and to be fair, the company had been working in all these areas before. I think what we've done, I've been there about 14 months now, is really hone the business case and the product case for each of these areas. But the areas where we're working with product sets and working towards programs of record and strategic capabilities would be hypersonics. So stuff that goes really, really fast and can go a long way. Survivable in a lot of conflict situations and provide our strategic decision makers with additional time on things. Space-based applications or access to space, so space mobility. We talked about moving stuff. Space mobility is very important, both getting stuff into space but also moving it around once it's there. And eventually that probably includes energetics in space, like space-based interceptors. And then the third area is rebuilding the industrial base for solid rocket motors. We don't have enough capacity in the United States to keep pace with the amount of magazine depth we need for those types of capabilities.
So talk a little bit about that. You hear in the news that if the United States were ever to get into a conflict, that we would lose our capacity to engage within about a week. And that's a scary thought. What are you doing about that?
So lots of estimates out there on how much depth of magazine capacity. That means how many shots you could get with different missiles and those sorts of things that the United States has. I think what we've learned is, very, very sort of specifically with the war in Ukraine and in the war in the Middle East, how many missiles you might go through at a very rapid clip. We thought we had a lot more sort of cushion than we actually have. And what we've learned from those conflicts is you actually use stuff up very, very quickly. So what we're working on at Ursa Major is building those new factories of the future. Very agile sort of manufacturing platforms, adept at doing different configurations, but also providing additional capacity. So not just prototypes, like it's cool to do stuff, but it's really cool to be able to do stuff at scale in quantities that matter to your customers. And so we're working really, really hard on building back that industrial capacity in the United States, trying to build it back very quickly, and build it back so that it can scale up and be pretty agile in terms of what you need and don't need. The other thing we've learned about the wars in the Middle East and Ukraine is that the war changes about every 90 days. So things that you thought you had in your arsenal, you thought was going to be really good, might not be so great 90 days from now when somebody figures out a countermeasure to that or the battlefield changes or something like that. So we're trying to build very agile manufacturing systems. We do a lot of additive manufacturing, a lot of 3D printing, a lot of other things that we think give us an advantage in terms of flexibility and adaptability to be able to make new things very quickly.
Let's talk about the cost ratio. Taking down a $2,500 drone with a $2 million missile doesn't make a lot of sense over time. You can make a lot more of those drones than you can of the missiles. What are you doing in that?
Well, we're working very, very hard to also increase the efficiency of those manufacturing plates. So if you don't have as much stranded capital in one type of system and you're pretty adept at it, that in and of itself gives you an economic advantage, just an overall capital cost and capital price point. So that's a big enhancement. It's also thinking about, what's the appropriate thing to shoot something else with. And so, it's not always the very, very large, expensive thing with an exquisite guidance system. It might be cheaper, smaller stuff. And so we've got a range of products across that entire sort of suite that we're working on to give, not just strategic capabilities, but budget capabilities to the people that buy this stuff, that represent the taxpayers, you and me, in making those decisions.
You talked about additive manufacturing. How's it impacted the company?
It's one of our key core strengths. Advanced manufacturing, I'd put it in the category to start with, but then we're really expert at additive manufacturing. So as the company got started, we got some grant money out in Youngstown, Ohio for America Makes and sort of Build Ohio Back Better type funds. And we got to buy some pretty exquisite 3D machines. So I don't know if you've ever watched a 3D printer work. I'm sure you have in your labs and stuff, right? And a lot of times what you see it printing up at polymers, composites, really cool stuff. We're really good at printing metals. So we do Inconel, we do steel, we do hard stuff. We've got some of our own alloys that we've developed. And with that 3D printing expertise we've developed, we're actually printing combustion chambers. Now, a combustion chamber on a rocket engine, inside the core, after you mix the gases together and you get ignition, gets to like 5,000 or 6,000 degrees Fahrenheit. Now, no metal can withstand that kind of temperature, so these are actively film flow cooled. And we're printing in, through that combination, really, I'll call them kind of exquisite types of things that would cost a lot of money to do forges or die sets on. But we can 3D print it pretty quickly and pretty economically, so that's really exciting. We're doing rotating machinery as well that for the turbo pumps that goes 50 to 60,000 RPM. Those are 3D prints, which is pretty amazing. Inside of a rocket engine that does, thousands and thousands of pounds thrust. So pretty fun and exquisite stuff. But it's really gives us a lot of advantages. So not just cost, as we think about that, but also adaptability. One of the things that we like to try and do, and we're on a number of different new programs that haven't existed anyplace else before, is we want to get really quick through the prototyping and qualification cycle. In order to be able to do that, you fail a lot of times. You try stuff out, doesn't work. Try stuff out again, doesn't work. Try stuff out again. Oh, yep, now we've got the engineering solution right. It doesn't mean we're not using a lot of rigor in the engineering process, but you're dealing with really, really hard problems and they haven't been solved before. You might not succeed the very first time out of the gate. With 3D printing, additive manufacturing, you can actually iterate really quickly. You can print a part, you can have a new part there in 72 hours with a whole new CAD design. You can try that out on the stand. You can try a new injector plate, a new turbo pump design. You're like, hey, what if we added a few microns over here? We tried the seal different over this way. Bam, let's get a printout. Let's try that on the stand. Let's see if we can iterate really quickly on something like that. So that's been a sort of a really exciting and part of the DNA of the company as we've gotten bigger and faster.
Yeah. What you're just talking about right now is not just having the capability of the additive manufacturing printing, but also the co-location of the people involved in that is critically important. Having people where you can design, test, and iterate so quickly. Talk about that. That's an area that you guys have your own test stands there, which you can see in the background here of an engine firing.
Yeah, it's one of our early engines. So we're on a 90-acre campus up just north of Denver, Colorado, kind of halfway between Denver and Fort Collins, a little town up there called Berthoud. And we've got sort of pretty good size infrastructure for a startup there, where we're most of the 3D parts get made in Ohio and then shipped to us, but then we do the post-processing machining there. The engineers sit there. Our test stands are there. We can the engineers walk out onto the production floor, talk to the guys who are guys and women who are actually putting things together, get instant feedback on, oh wow, I saw that seal on the CAD drawing. I didn't quite know this was how it was gonna match up where those two objects made it together there. And so you kind of get this good, vibrant sort of feedback loop going among the people at the company. And then you get to go out, you get to take it right out to the test stand, you get to try it out. And you turn stuff on. And if it doesn't do what it's supposed to, you get rapid feedback, because sometimes it's,
In the case of a rocket, rapid feedback is an explosion.
yeah, it can be. And sometimes, there's a lot of critical parts, right? Like there's, you think about this, like the valves and the timing on the valves, and the microsecond sort of getting a rocket engine to light is not an easy thing. And so you get this inside that entire complex system, and we're capturing lots of data points at really high hertz rates. From pressure and temperature and cameras all over the place. You get really rapid feedback. You're like, well, that was interesting. This is like a 12-year-old kid's dream job, right? Because we're just lighting stuff on fire and we're trying it out every day. And we really iterate quickly. If you come out to our facility, you would notice that like we don't go months and months without a test. Sometimes we don't even go an hour without a test. Every day there's something being tested out there. Something's out on the stand. Something's going through a high qualification process, and we're getting feedback from that. And that's just like really a fun place. It's like this constant lab there.
So what do the neighbors think of that?
They're very used to us. We've got lots of, it's a pretty remote area to start with, but we're very cognizant of those who are around us. We're very, very safe in terms of how we do it. We do have some restrictions on when we can have certain noise things. We measure decibel levels all over the place. Every once in a while, things are a little louder than we expected them to be, and we adjust.
So you're still a young company without a manufacturing line. Tell us how important manufacturing is to you, how you think about it, and what you're doing about it.
So maybe just a little correction there. We actually are at low rates of initial production on several articles. The Hadley engine, we can do about one of those a week right now, which $50 a year for a rocket engine, not too bad. Pretty good price point for that. Its successor, the Draper engine, which is a non-cryogenic version, we call it a tactically relevant version. We could do about one a week of those as well right now, including an all-up missile system. And so we're at low rates of initial production, I'd say. We're working through qualification very quickly, but we are working now also to expand into much higher quality and quantity levels for our ultimate customer, the U.S. government. That's a big change for the company. We're blessed with some really good talent that have worked in places like Tesla, that have worked in places like Flextronics, that have worked in places like the automotive industry and other places where they've ramped up into high levels of production before. And so we're aware of those challenges. We're well underway into some of our expansion plans on that front. And we think we'll not easily, but we'll absolutely get there on our customers' timelines and the quality levels that they need.
So you, on one of your solid rocket motors, those are very different than the liquid propulsion systems. And you have to have, those rockets work a little differently. You might want to explain that a little bit. But talk about how you were able to develop the energetics there for those rockets so quickly.
Well, so maybe just a little bit of a quick sort of rocket 101 here. For rocket engines, liquid rocket engines usually use two different types of liquids, oftentimes a cryogenic. So SpaceX, for example, would use liquid oxygen and kerosene, liquid oxygen being the oxidizer and the kerosene being the fuel, to power something like the Falcon 9. That's what our Hadley engine, the one you see behind me, does as well. That's just a smaller engine that has different applications for that. And what those do is you mix the two liquids, you get to combustion, you turn turbo machinery, and you get a lot of thrust out of the engine. The advanced version of that, Draper, has no cryogenics. So that means you can press a button and it takes off. So you don't need to supercool anything to start with. You don't need to be doing venting or any other kind of conditioning of the metals before you start it. And that's why we call that one tactically relevant. We want it to act more like a solid, which means it's storable. You press a button, it activates exactly when you need it to. Because for a lot of these applications, we're not doing launch-based operations. We're doing things that need to either move very quickly in space or be an interceptor or be a type of offensive capability that for that mission profile. Solid rocket motors now, so liquid rocket engines, now solid rocket motors. Solid rocket motors are much more like what you think about like with fireworks, right? There's some kind of energetic in there. In this case, it's not black powder or gunpowder like we might use in fireworks applications, but really, really advanced chemistry for aluminum and ammonium and some different types of perchlorates that create a very, very high energy chemical. And what we do is we ignite that chemical and then it burns. And it burns really quickly with an awful lot of, so if you see a missile flying off a ship, that's a solid rocket motor. If you see a missile kind of falling off an airplane and taking off, mostly that's a solid rocket motor as well. And they're very advanced defense applications. We're doing both of those. We did a startup within a startup about 2.5 years ago. And some of our, admittedly, we like to think of them as brilliant engineers and scientists at the company, said, hey, what other things? We seem to be really good at propulsion. We understand nozzles. We understand this. We understand that. What other things do we have here that we could do as applications for our customers? And so we started up our solid rocket motor team. And then we're under contract with the Navy, the Air Force, and through one of our prime partners with the Army. So we're hitting on all three services right now, and we're ramping from low rates of production through qualification into higher rates of production there.
Wow. Yeah, and there's a great opportunity there. I mean, I think you've at least doubled the size or doubled the potential of the company with just that. So one last question before we get to the audience. Something that everybody wants to know. How do you go about getting government contracts? What's the key there?
So the first key is patience and enough capital. Yeah, everybody's laughing, right? Because it can take a long time. These are generally long sales cycles. They're long development cycles. It takes the military industrial complex even with acquisition reform, they're not going to go really super fast on stuff. So whatever your business plan looks like, take a 2X or a 3X on it and make sure you've got enough capital and cash to ride that out. Because it could very often take longer than you want it to, longer than you think it should. And that's just the nature of that customer that you're dealing with. The second thing is really think about what problem you're solving. An awful lot of people come in and they say, hey, I've got a great technology, buy my stuff. It doesn't work that way, right? It doesn't work that way. You don't go to stores and you don't say, hey, I've got something really good. Would you just put it on your shelves? Costco's going to look at you and be like, who are you? Like, why are you here? Why are you telling me that? So think about what the problem is that your customer is going to have. If your customer is going to be the U.S. government, how it is that they're looking at the problem. And we like to say the U.S. government is not one person. So even if somebody inside the U.S. government gives you a good signal, that doesn't necessarily mean the U.S. government's going to go out and buy it tomorrow. What does Congress think about it? What do the appropriators think about it? What does the administration and the Office of Management and Budget think about it? What do the strategic people inside the Department of Defense or the Department of War, I think they're calling it now, think about it that make sure that this is an actual strategic capability the United States needs. Solve that problem. If you hit that problem, productize it. If you productize it, now you've got something that they can actually buy. They don't have to just do technology development with you, and then prove to them that you can deliver it. If you can do that, and you can do that repeatedly, you look really, really good to that customer. You help them look good. You help solve their problem. And that's what we're in business for, right? We're solving people's problems and making our investors money. So we're solving the customer's problem, doing it at a price point that makes sense, and then hopefully that makes our investors a lot of money. But there's no easy answers to it. You got to grind. You got to do the work. And at the end of the day, you still have to have something that they need.
Well, everyone, thank you very much. It's been a learning experience. Thanks, Dan, for being here. Thanks.
Thank you.
Appreciate it, Joe.
Yeah, thank you.